Welcome back, dear students. So hope you might have revised your last class. In the last class we started current electricity, and we have got some introduction about charge, the flow of charge, rate of flow of charge is what is current. We just got some introduction, we did some problems too. So in the last class itself we have discussed, like on the same day itself we should revise the topic. One more thing which we need to do, another tip is, before coming to the class you should revise those topics. You should be in that mode. For example, if you are studying current electricity, then how much current electricity is covered? You should cover all those parts. Then you should start seeing the class, or you should start attending the lecture. So it will be very easy to understand. We should make our brain what current electricity mode. If you are studying magnetism, then magnetism mode. Suppose if you are studying biology, then you should read that part. Then if you sit, you will get a connection. So that is what. Okay, then we'll start. Right, so last class how much we have studied, let us revise once. We have studied rate of flow of charge is what? Current. If the charge flow is constant, then current is nothing but Q by T. If the charge is varying at a different time instance, we are getting different values of charges, then we'll have I average is equal to Q2 minus Q1 by T2 minus T1. Likewise, now if the charge is a function of time, if the charge is varying with a function of time, at the same time if you are finding I average Q2 minus Q1 by T2 minus T1, if we need to find instantaneous value of current, that we need current at a particular instant, then I instantaneous is equal to dq by dt. Differentiating the function of the charge with respect to time, we will be getting I instant. We saw the equation how to solve, how to do differentiation, we just saw that also. Suppose if we need to find charge, if the current is varying, then integral T1 to T2 I dt. That time this current will be a function of time. Okay, so we have seen this and we did some problems also. So again, same topic, current, we will go a little more detail into it. There are different modes for current. For example, current can be made using translatory motion. What is translatory motion? Suppose if something is moving like this, or something is moving like this, that is straight line motion. This is called translatory motion. Okay, then this kind of motion, circular motion. So there are different types of motion. So whatever we have seen yesterday in the last class is the current due to translatory motion. Circular motion also we have done some problems, but we will see it again once. So one mode is translatory motion. So far we have seen this translatory motion, and I is equal to Q by T, or I is equal to delta Q by delta T, or I instantaneous is equal to dq by dt. So all this comes under translatory motion. Okay, now even these things, these basics can be applied in other modes also. Second thing is Suppose a charge is moving around a circle like this. Okay, one charge started from here, it is moving like this, keeps on moving like this. This will create some current. So same thing, I is equal to Q by T, Q by T itself. But here, what is this T? Whatever this charge, that charge we can put here, okay, whatever it may be, Q divided by, what is the time? That is time period T. Now, the time taken for the charge to move one full cycle is what is called a time period T. What is the formula for time period T? Either 2 pi by omega, 2 pi by omega, where omega is the angular frequency. Substituting that here, Q by 2 pi, then if we put omega, this will come to the numerator. So Q omega by 2 pi. So I can be Q omega by 2 pi. Then from circular motion, we used to study V is equal to R omega, where R is nothing but the radius of this circular motion. So omega is equal to V by R. Substituting that again, we get I is equal to Q by 2 pi. In the place of omega we can put V, and here the R will come. This is another formula for finding current if a charge is making circular motion along a circle. Okay, so Q into V by 2 pi R. Now another thing is, you have heard about frequency. What is frequency? The number of times a charge moves around in 1 second. How many number of times a charge moves around in 1 second? Number of cycles in 1 second. That is what is frequency. For frequency, if we write f is nothing but 1 by t. This is time period. So putting this in that equation, what can we do? Again, from this, I is equal to, instead of Q by T, we can have QF. So from this basic formula we came to all these formulas. So this is if a charge is making circular motion, then we can have all this. So make note of this, pause the screen and please note it down. So using translatory motion of a charge, you're using rotational motion or circular motion of a charge, we find. Third mode which we use in this chapter is nothing but, if a resistor is like this, if this is R, the voltage across this resistance is V, then we find I is equal to V by R. This voltage across this resistance divided by the resistance will give us current. So regarding this we will study in detail in circuit theory of the same chapter, not getting into it much into the details. We will see it later. Another question is this current, what is the unit of current? Unit of current is what? Ampere. So unit of charge is Coulomb. So when we take the dimension, finding the dimension of any physical quantity is important. whatever physical quantity we come across, we will find the dimension of that. See, so for example, force, you know, it is mlt raised to minus 2. Likewise, we used to find dimension. For finding dimension, we always use what? We will be using fundamental units. Fundamental units only we will be using. So coulomb is not a fundamental unit. Coulomb is not a fundamental unit, but ampere is a fundamental unit. Ampere is a fundamental unit. So always keep this in mind. Ampere is a fundamental unit. Ampere is a fundamental unit. So when we find the dimension of a charge, I is equal to Q by T. I is equal to Q by T. So Q is equal to IT. So current unit is ampere. Time we can put the dimension as T. So dimension of a charge is nothing but AT. So we are using the fundamental unit here, ampere, to find the dimension of charge. Another thing which we need to understand is current is a scalar or vector. Please think about this, whether current is a scalar or vector. So current has magnitude and current has direction also. So we have studied something which has direction and magnitude. We call them what? Vector. So current has both magnitude and direction. So current is a vector. So current is not a vector. Current is not a vector. Why? Because suppose if a vector A acts, another vector B acts like this, and if we put an angle 60, what is the resultant vector? What is the resultant means what is A plus B? How we can add vector A plus vector B? We have a system like addition of vector A or resultant R is nothing but resultant is equal to root of A square plus B square plus 2AB cos theta. We have studied this in vector analysis or vector algebra in current in motion in 2 dimension in the first year, in the +1. If you remember this, well and good. If you don't remember, at least understand it now. The resultant of 2 vectors is nothing but A square plus B square plus 2AB cos theta. So this angle matters. Now suppose if 1 ampere current is coming like this, another 2 ampere current is coming like this. If the angle between these two are 60 degree, if third line if we take 1 ampere, 2 ampere, this is going to be 3 ampere. We don't consider this angle, whether this is 60 degree or 90 degree, whatever it may be, we don't consider that angle. If we consider that angle, we will have to put 3 square plus 2 square plus 2 into 3 into 2 into cos 60 we will have to put. That is not at all required. That is, current is added What? In what way? Just linear algebra, not vector algebra. Okay, using linear algebra. Just if you take 1 cup of milk, adding another 2 cup of milk, you will be getting 2 cup of milk. 1 cup of milk, again adding one more cup of milk, you will be getting 2 cup of milk. We don't bother at what angle you are pouring into the vessel. So linear algebra, just primary school mathematics. When we come to physics, when we are dealing with the vectors, we will have to study vector algebra and we apply that carefully. That is not required here in current. So since current is not following vector algebra, current is considered as scalar. Another terminology also you can use, that is nothing but tensor. Current is a tensor. It has some characteristics of vector, but it is a scalar. So those kind of things you can say tensor. So that is also there. But here we can say if tensor is not there in the option, you can mark scalar. So current is a scalar quantity. Now suppose if this is a conductor, electrons are flowing in this direction. So due to the flow of electrons, because of this electron, positive charge will be flowing towards left side. Suppose electrons are flowing in the right direction, there will be current or positive charges will be flowing in leftward direction. So we can say current is in this direction. So due to this electron, current will be there. Other than that, suppose there are ions. There are some ions, any positive ions. They are positively charged particle. So if the ions are moving in rightward direction and electrons are moving in the leftward direction, then current is due to the charge due to ions in the rightward direction plus the charge due to electrons in the leftward direction. This electron that is moving in the leftward direction will make positive charge to move in the rightward direction, which is of same magnitude of charge but positive direction, rightward direction. So this by T. So we should understand, if there are two charge carriers, in a conductor, we should consider those two charge carriers while calculating current. There will be current due to electron itself. Maybe that may be the only source of current. Other than that, if there are some other charge carriers other than electron, then we should consider that also. Okay, so in that case, current could be due to positive ions plus due to electrons divided by T. So this direction also matters. If the electron direction is in the opposite direction, we should consider. And suppose this is a conductor, ions are moving in the right direction, some electrons are also moving in the rightward direction. So obviously the positive charges will be moving in the opposite direction of ions. So that time current will be the charge due to ions minus the charge due to what? Electrons divided by T. Why I have taken minus? Because their direction of currents are different. So this also we need to consider. If the direction is different, if the directions are same of both the positive charges, then we can add it and take. So here one question: In a neon discharge tube, 2.9 into 10 raised to 18 neon plus ions move to the right each second, while 1.2 into 10 raised to 18 electrons move to the left per second. The current in the discharge tube. So here I is equal to Q due to ions, Q due to electrons divided by T. So what is the charge due to ions? So how many charges are there? 2.9 into 10 raised to 18 neon plus. So 2.9 into 10 raised to 18. This is actually N, number of charges, into how much? 1.6 into 10 raised to minus 19, plus how many electrons? 1.2 into 10 raised to 18 into 1.6 into 10 raised to minus 19, divided by time is 1 second, because this many number of charges are moving per second. So do this, either option A or option right, because current is moving to the right, not option B, option C or option D. So we will be getting 0.66 amperes, that also towards right. Option B is the correct answer. So neon plus ion, we have taken the charge as 1.6 into 10 raised to minus 19 in the question where we found current. So why we have taken 1.6 into 10 raised to minus 19? So for electron we know the charge is 1.6 into 10 raised to minus 19 coulomb. Charge is negative. This is neon plus. Same charge we are putting, but it is positive. Why? Because neon becomes neon plus ion by releasing one electron. When it loses one electron, then it is leaving 1.6 into 10 raised to minus 19 negative charge. So that is why neon plus will have 1.6 into 10 raised to minus 19 plus charge for neon plus. That is the reason we have taken its charge as like this. Next question. The potential difference applied to an X-ray tube is 5 kilovolt and the current through it is 3.2 milliampere. Then the number of electrons striking the target per second is, that is the question. So I is equal to Q by T. I is equal to Q by T. And Q we know it is nothing but NE. Number of charges into charge divided by T. NE by T. Now what is N here? Number of electrons we need to find. This is what we need to find. So N is equal to, current is given here, I into T. Number of electrons striking the target per second is. So I into T divided by E. So from this I is equal to NE by T, we can take N is equal to I into T by E. So I is 3.2 into 10 raised to minus 3 into 1 divided by 1.6 into 10 raised to minus 19. So here this will become 2. So what is the answer? 10 raised to minus 19 will go up, cancel with the 10 raised to minus 3. So we will be getting option A as the correct answer. Another question, a beam of electrons moving at a speed of 10 raised to 6 meter per second along a line produces a current of 1.6 into 10 raised to minus 6 ampere. The number of electrons in 1 meter of D. This is the question. So here again we have got current is given, I is equal to Q by T. Time is not given. Instead, they have given speed. They have given speed of 10 raised to 6 meter per second, and they have specifically asked the number of electrons in 1 meter of beam. So number of electrons we need to find. So definitely we will have to make this Q into Q as NE. Divide by T. So we know speed is equal to distance by time. Distance by time. Or velocity is equal to displacement by time. Anything is fine. So here time is equal to x by v. So substituting that here, we will be getting x by v. So I is equal to NEV by x. So from that we get N is equal to Ix divided by N into E. Okay, so substituting the value there, we will be getting the answer. So N is equal to I 1.6 into 10 raised to minus 6 ampere into, they are asking the number of electrons in 1 meter. So 1 meter divided by N we need to find here, right? So N we need to find, where is the formula? Yes, this is not required. Ix by this is V. Where is velocity? Yeah, 10 raised to 6 into E. 1.6 into 10 raised to minus 90. So here 1.6 can be cancelled off. Then 10 raised to minus 6 into here 10 raised to this and this, when we cancel we will be getting 10 raised to minus 13. When it goes up 10 raised to 13. So 10 raised to 7 we are getting. Answer is option B. Next question. In Bohr's model of hydrogen atom, the electrons move around the nucleus in a circular orbit of radius 5 into 10 raised to minus 11 meters. Its time period is 1.5 into 10 raised to minus 16 seconds. The current associated is. So this is what? Circular motion. So current is generated due to circular motion. So this is how it is. Electron in this hydrogen atom moves around and makes current. So again I is equal to Q by T. What is Q here? Ne by T. So how many number of electrons are there in hydrogen atom? In hydrogen atom there is only one electron. So 1 into 1.6 into 10 raised to minus 19 divided by time. What is the time here? We need to put as time period. So this is 1.5 into 10 raised to minus 16. So time period is also given. So by solving this we will be getting 1.07 into 10 raised to minus 3 ampere. Option D is the answer. So when doing circular motion, Q by T, time period we can take it as time, we can take as time period. If velocity or speed, if we need to consider, we need to consider the tangential velocity also. So this is how we can solve these kind of problems also.